wondering what this thing is mainly about. I heard it's a lot about STEM and
It is.
STEM
It's
programs.
science, technology, engineering, mathematics, and how all four subjects come together to really show kids what they can do with those four subjects.
That's amazing because I see this.
Have you seen Mr. Robot?
The robot, yeah. I heard about him. I'm trying to offer people Cheetos.
Did you get a frontal shot of him?
Oh, I think so.
You should see the light, the headlights, the eyeballs.
Yeah, it's amazing. That's so cool. So, I was just asking you, like, I know you're here as like the tech ed teacher, and so you know a lot about technology. Like, what like, amazes you about this type of stuff?
The fact that this Mr. Robot came in 12 boxes with 5,600 pieces. Whoa! And a 280-page electrical manual of how to build it.
5,000 pieces?
It took the kids in the Lego Robotics Club 6 months, and they built it.
That's amazing.
Started from scratch.
So like all these are like tiny gears and like
little gears, little motors, all the servo motors, the gears, the torso, the armor plates, the batteries, all the wiring. If you can see inside, you get all the wiring. And this, it's a Lego, an EV3 Lego brick. That's the brains of the outfit.
Oh, so this is like.
Programmed. Yes, I am.
This button thing controls the whole robot. But then we connected this PS2 remote.
Whoa, time out. Because I see there's water. There's water in the controller.
It's a PS2 remote.
It's a PS2 controller, but it's a fancy snatcher.
But why is there water in it? Like,
just to make it look nice.
Just to make it
that
look
doesn't
nice.
do anything.
I thought it was like hydraulic technology for a second. I was like,
nothing else. He even tells jokes.
Oh, he like talks?
You gotta get really close. It doesn't.
Abina, put your here.
You know why he laughs? Because the kids told me that I have really bad jokes.
Yeah.
So they built a robot that would laugh at my jokes.
That's tough, Mr. May. That's tough. And I saw, the blender and everything, and I heard something about DNA. So that says DNA extraction. So I'm curious about what that means.
If you look at what they're doing is the students are teaching how to extract the DNA from cells. First they're using some soap. You can see first they're using some soap to break the membranes apart. And then they're taking the DNA and they're using some meat tenderizer with enzymes to break down the proteins, the histone proteins of the DNA. Then they're using alcohol to separate the DNA. When they're all done, I'll show you what it looks like. Let's show him some of the protein, what it looks like when it's out. See that gooey stuff on top? That's the actual DNA. See that white stuff? That's the actual DNA. You want to show it?
Yeah, so I'm doing a little demo on recycling and composting. So we took some compost from our compost bin at our center, just kind of showing how it looks, throughout the composting process, and some samples here. And then we're putting some of the samples under the microscopes to see what's living in the compost, like little worms, mites, little beetles, things like that, and then any sort of food particles in there. And then over here, we just have a little demo on how long it takes for different items to break down in the environment. And kind of matching them up to the years here. So it's a little
VR.
This is a virtual reality machine that you can draw art with. And when you're drawing the art in virtual reality, you look at the screen. You take a picture of the screen, and it shows you what you're making.
So is that person doing like a virtual? Like they're drawing something right now?
Yeah, they are. They're drawing. If you look at the screen.
Oh.
Oh, there you go.
Tell me a little bit about what this the bottle is for. Like, what are you doing?
We're making lava lamps.
Lava lamps. Okay. Do you know how you're making lava lamps?
We're putting the vegetable oil in the water because they separate, and then we're putting these little tablets in with food coloring. Did you put 10 drops?
Oh, okay. So, do you know why it works?
Well, they're different liquids, so they separate.
Okay.
Different consistency, right? Yeah, different consistency. So do we put these in?
I did just a few seconds ago. You're yelling, I did it. You mind telling me what you did?
So what I did was I took a balloon, I put a bunch of Vaseline on it, and then on the side. So then I put this sticky thing through the balloon without it popping.
That's awesome. So like the balloon, is it like popped? How so
It didn't pop.
do you, so by any chance, you know how the balloon like made that happen?
No, but I'm thinking maybe it sealed like around a gap, maybe. I don't know.
I don't know. It's magic almost,
Yeah.
right? Yeah, it's magic. Oh, somebody wasn't as successful as you.
Yeah. It usually pops.
Thing is, because I'm interested. I like boats.
You have to,
that's good.
You have to use
Oh,
foil,
this is it.
2 pieces of foil to make a boat, and then you have to see how many pennies you could
You know what?
you could balance on your
standing.
boat without it sinking.
So is there like, so what's the highest amount of pennies you've gotten so far?
Like 6.
Like going on over here? Like what
This is Yes Camp, club for 5th, 6th, 7th, and 8th graders, or during the summer. Over here, you can see the 6th graders project.
I just want to remind
There's a bunch of like cars, and you build rockets.
Two of the locations where we have activities. We have
fun.
outside the BioBus and the Alpha Rockets.
During
You're on the
7th
map,
grade,
but you might
one
not
of
have
the main
noticed. They are
projects is
outside.
this
You can go
hydraulic
through the
wall.
technology hallway, or you can go out the main
Well, can you
entrance.
tell me a little bit? Oh.
And in
So you use
room
water to, like,
162,
move
which
it.
is
because the thing
right
is,
across
inside
from the
these two,
cafeteria,
there's
we
there's
have
only so
a
much
voice
matter. So
activated
when you
drone
push on one,
from
it
Iona
goes
College
all the way
Computer
here
Science
and
Club.
pushes to the other.
Please go out
So
to
can you
room
tell us-
This is one of
and
my
you can also get a
favorite
sticker
things.
from them.
This is
So
the
all of those
useless
activities
box.
you can get
The
stickers,
what
not
box?
just
The
ones in this
useless
room.
box.
The
And if you
useless
just want to like flip that lever, you'll see.
Wait, so you guys were playing around with the useless box?
Yeah, you'll see why. Just push the lever and you'll see.
Wait.
It's a little machine that turns itself off.
Stop it. Are you kidding me?
Yes. You get
Wait,
it.
you have accomplished.
I did
making-
not build
you-
this, so stop complimenting me.
Okay. Whoever built this should be proud of himself.
Yes.
Because they made
You can build this
a
if you come
useless
to the
box.
club. Yeah, you can come. You can build this if you come.
What's your favorite part of the thing, the event?
My favorite part was the forensic part.
The what part?
The forensics part.
Forensic part.
It's like
What
a
is
crime
that?
scene. It's over there. You like
Oh.
do a crime scene on like a piece of paper. Yeah, it's like bullet shots. Pretty cool.
So you're like your own detective and everything? And
Yeah.
so how would that like science really, like how did that tie into science?
Well, like, okay, so you had to like measure like the feet, and you had to write it on a graph paper, and like 2 boxes is a foot. So you would like, if it was 7 feet, you would go like 14 boxes, and you would like draw the area, and then you would find these like little points where they have bullet shells, right? And then you would go and measure that from the sides, and then you would mark that on the paper, so you could see like the crime scene.
Put the time. That's cool. That's cool. Very cool. Thank you.
Okay, so we're from Science Research, and it's a program at the high school, and so essentially we get to pick any topic that we want and research it. So over the summer, we work in laboratories, and then we compete with the research that we do in those laboratories. So I studied epilepsy, and I worked directly with a rat model. So
Wait, you performed like seizures on a rat?
So yeah, we induce the seizures in the rats, but it's all in the name of science. So
And I researched finding a target treatment for diabetic kidney disease, which means we're trying to prevent the disease from even happening. So we studied that we're using cells.
So it's like medical research, cellular research. That's really cool.
we also have people who do like astronomy, computer science.
Other bio things.
Let me look a little bit like what does the board say? Like, is that research about the
Oh, these are not ours. So this is what a 10th grader would make. So we read previous research articles, and then we kind of propose our own study. So this is what our regular poster would look like. We have an introduction, previous research with a bunch of articles we've read, a problem, goal, hypothesis, methods, results, discussion, applications, future research, and conclusion.
Yeah. So actually, when we go to other competitions, we use posters that are about 1.5 times this size, and they're made of wood, and they're ginormous.
Yes.
They're really cool. They're so cool.
So what did you find on the poor rat?
To go into, I guess I'll just tell you some specifics.
Okay.
So we found that, so you know how with a seizure, like there's a big like movement and it looks pretty chaotic. So
Yeah.
we found that in some cases there's that chaotic activity on an EEG which measures the electrical activity in your brain, but they weren't showing any behavior, so it was super subtle.
Oh, that's interesting. Thank you. Thanks both of you. Voice activated drone. That sounds cool.
So what we do is it takes our voice and we send it to a Google server, and the Google server sends us back the text. And with that text, we implement it into our program, our Python program, and we translate it into what the drone understands.
Oh, that's like, so it's like translating. So it's not like it understands your words, but your words are kind of translated, and then it like kind of gets those codes in.
Exactly.
That's cool. You can make it do like all sorts of stuff.
Right.
Cool. So my name's Travis. We're from Mac Inspires. We have a makerspace in Larchmont, Mamaroneck, and in Greenwich. And we teach about 300 kids a week, a lot of really cool science, technology things. Today we brought robots.
That's cool, yeah.
Yeah. We have over 100 robots.
100 robots, right?
Yep. So these are...
just keep talking.
These are our Dash robots, which we have about 10 of, and they're really cool because you use a code language that's like blocks. You don't have to do letter by letter.
So it's like... So it's like you block it, you like kind of...
Yeah, almost like coding with Legos. Yeah, with pieces. Yeah, exactly. And then those robots over there are an example of like other ones that require like letter by letter coding. They're a little more advanced. Yeah. Hence like having 100 robots. We don't have like 100 of the same robots. We have different robots that have different challenges.
That's awesome.
Yeah, thank you.
Like, is there like special like AI and like coding and stuff?
Yeah, it's funny you asked about AI. This summer is going to be our first time we do AI cars. Like we're gonna have like a map at the makerspace, and these cars that have cameras, and then they're gonna we're gonna code them to like navigate around the map.
Like Transformers? Like Transformers?
Well, let's Transformers more like Tesla auto driving.
Yeah, Tesla. That's awesome. That's cool.
I'm Meredith.
Nice to meet you. Yeah. So I just want to know, because I kind of came in late, like what we were zooming in on.
Totally. So right now what we're looking at over here is a little bit more. Right now we're using an electron microscope, which is this microscope right here. And most people see it and they're like, what is that?
That's a microscope.
And yeah, that's like everyone's reaction to it. There's a little cabinet over here that opens up. We can't open it up right now because it takes about like 10 minutes to close it. So you close it and you have to press a button and it takes a while. So I'm not going to do that right now.
Okay, no problem.
But what I will do is I'm going to zoom out a little bit. And right now what we're looking at is the filament and then the anthers of a plant is what we're looking at. We're looking at this. And where this comes from is from the very center of our plant. And it's so tiny. If you look, here, watch, we can pull another one out too. We got lots and lots and lots of them. And you can see. Bingo. Cool.
Oh, that's small. So that's what's on the...
And that's what we're looking at right over here and over here. It kind of changed shapes a little bit. So inside this microscope, what it has to do, in order to look at the sample really, really clearly, we actually have to get rid of the air. So you have to suck all of the air out from inside of there. So what it does is it does something called building a vacuum. So it makes a vacuum by sucking all the air out. And that's actually why this shape doesn't look exactly how it looked a while ago, because like vacuums, they can affect how things look. So, and like the longer it's in there, the more it's going to affect it. All these little dots over here, those are all pollen. And what we can do is we can go ahead and we can zoom in. And we can zoom in, and we can zoom in, and zoom in, and zoom in, and keep going, and keep going. Right now we're about 200 times zoomed in. And each one of those circles that you're looking at, those are all individual grains of pollen. So like that's pollen, this is pollen.
So that's what bees come in and like, they collect them and everything.
So bees will come in and they'll get them like all over their fuzzies, like the fuzzy hair on the side of their body, and then they'll go to another one of these flowers and they'll bring it over with them.
A little bit?
Yeah,
like,
one of the organizers.
Yeah, one of the technology.
Actually, you reminded me, I need to announce that it is supported by National PTA and Bayer. So they helped fund the event. They came up with a lot of the ideas that we have for it. And then we invite other local institutions from the community to come out, meet the kids, because they really do want to meet the students, especially at this age when it's good to get them interested in
developing
science.
and everything. Yeah, it's cool.